Hi guys, so today we're going to do lesson 2.1, the second part, where we review quadratic functions and their graphs so that whenever we get to the modeling portion, we have all of this information fresh in our minds. So the first thing to review, I think it's important to go through the parent function. So the parent function, y equals x squared, or f of x equals x squared. The graph is a parabola. If I were to do a little XY chart, I can remember the point 0, 0. If I plug in 0, it returns 0. If I plug in a 1, I get a 1, or if a negative 1, I get another 1. So we're going to those 2 points. If I plug in 2, I get a 4, or a negative 2, I get a 4, giving me this symmetry. And I'll go out one more. If I get to plug in 3, 3 squared is 9. Plug in negative 3 squared is 9. And obviously I could keep plugging in more points. And as I plug in more points, I would get this parabola that continues and goes on forever and ever up towards infinity. So some vocabulary, this turning point here is called the vertex. And that's where it changes from increasing to decreasing or decreasing to increasing. Every quadratic has a vertical line called the axis of symmetry. That cuts the parabola in half per se, so if it were to fold over the axis of symmetry, it would go onto itself. If I look at this parabola, it's got one interval of increasing and one interval of decreasing. So we would say that the parent function is increasing for all x values in the interval from 0 to infinity. So that's just saying from x equals 0 to infinity, that function is increasing. And then it is decreasing for all x values in the interval from negative infinity to 0. So if I'm looking at negative infinity to 0, it's decreasing. It's really important that we're looking at, remember we're talking about these x values right here, from negative infinity to 0, and then increasing from 0 to positive infinity. So when I'm talking about these intervals, it's intervals of x values that are describing what the y values are doing. And I'm not including the 0, of course, because at 0, at the vertex right here, it is turning. It is neither increasing nor decreasing. It is turning at that point. Let's also talk about the domain and the range. So of the parent function, the domain, remember the list of all x values that I can plug in that give me a real y value. That's all real numbers. I can plug in any x value I want, and you can denote it with this double-lined R, or you can say negative infinity to infinity. It's up to you. Now for the range, the y values, I don't have any y values in the negatives. Whenever I plug in x values, it only returns positive values and 0. So 0 is the smallest y value I get, and then I have y values going all the way up to infinity. There are 3 different forms of the quadratic that we see pretty often, and so we're going to review those. The first is the general form, or the standard form it's sometimes called, and that's y equals ax squared plus bx plus c, where a, b, and c lie in the real number set, so they're just numbers. If I'm going to graph a quadratic function that's in general form, I've got an example for us to do. There's steps that are the easiest to take. So if I have y equals 2x squared minus 8x plus 1, first let's identify what our a, b, and c are. My a is 2, my b is negative 8, and my c is 1. So first, I'm going to find that axis of symmetry, the AOS. And it is always going to lie at x equals negative b over 2 times a. So I've got x equals negative 8 all over 2 times 2. So 8 over 4 which is 2. So I'm going to go ahead and start my sketch by outlining that axis of symmetry. 1, 2. And that's my axis of symmetry. It's really important that when you're doing your axis of symmetry that you have x equals the number because it is a vertical line. Now my second step is going to be to find the vertex. Now I know the vertex is going to be an ordered pair, and I know it has to lie on the axis of symmetry since it's the turning point, so I know that the x-coordinate is going to be 2. So to find the y-coordinate that corresponds to that x value, I'm just going to plug it into my function. I'm going to evaluate it. So I'll say f of 2 equals 2 times 2 squared minus 8 times 2 plus a 1. So order of operations, I'll do the 2 squared first, which is 4, and 4 times 2 is 8, minus 8 times 2 is 16, plus 1. So I have negative 8 plus 1. The y value is negative 7. So I've got my vertexes at 2, negative 7. So 1, 2, 3, 4, 5, 6. Here's negative 7, 2, negative 7. Now something to remember, I can put this back up in my notes, is this a value in standard form, it will tell you if the parabola opens up or down. If the a value is greater than 0, if it's positive, my parabola is going to open up. And if the a value is less than 0, well then it's going to open down. When I look at my a value of 2, I know this parabola should open up. Now the next thing I need to do is I need to find really just one other point, and then I can use symmetry to flip it over. I think the easiest point to use is going to be the y-intercept whenever I'm dealing with a parabola that's in standard form. So I need to get another point. And I like to use the y-intercept because plugging in 0 is super easy. So if I were to plug in 0, let me scroll up a little bit to see my function again. Notice the first term is going to end up canceling out. Oops, I need to put an equal sign here. Equals 2 times 0 squared minus 8 times 0 plus a 1. So I have 0 minus a 0 plus a 1, giving me a 1. So my y-intercept is 0, 1. Notice if you plug in 0, I can make another note up here. The first two terms will end up canceling, and you're just left with this c value right here. So whatever this constant is always going to be the y-intercept. So now that I've found that y-intercept, I can use symmetry to flip that about that axis of symmetry and get my last point that I need to get my sketch. So here, this is 2 units away from the axis of symmetry. So if I go 2 more units out, I land here at the point 4, 1. And now I have everything I need to sketch a graph of my parabola. Not too bad. And now I can answer the following questions, like what is the domain and the range, and intervals of increasing and decreasing. So notice my domain is still going to be all real numbers. Oops. There we go, all real numbers. Or you can do the negative infinity to infinity. My range looks like this time it starts at -7 and goes all the way up to infinity. I like going from left to right, so I start out decreasing. So from negative infinity to +2, this parabola is decreasing, and then from 2 to infinity, it is increasing. So these are the steps that you outline to graph a parabola if it's originally given to you in standard form. And just to review, remember the A value tells you if it's positive or negative. You can see that on site. And the C value will always be the y-intercept. Now let's talk about intercept form. So intercept form is usually y equals a times x minus p times x minus q. And the reason that this one is super useful is because p and q are x-intercepts. This a here is a constant out front. So a is just a number in the real number set. And again, a is going to tell you if it's opening up or down. So if your a value is greater than 0, it'll open up. And if a is less than 0, your parabola will open down. So here we have an example. Y equals 3 times x minus 2 times x minus 8. Let's review really quickly like why exactly these are x-intercepts. So if you recall from the linear review, to find an x-intercept, you plug in 0 for y, and you solve. So if I were to plug in 0 for y, I'd end up with 0 equals 3 times x minus 2 times x minus 8. If I were going to solve for x here, I would just go ahead and get rid of that 3, because 0 divided by 3 is just 0. Giving me 0 equals x minus 2 times x minus 8. So now I'm going to use my zero product property. Now, remembering zero product property, it says if a times b is equal to 0, then a is equal to 0, or b has to be equal to 0. Because the only way for a times b to equal to 0 is if one or the other is 0. So in this case, like this would be my a, and this would be my b. In order to make this true, either x minus 2, my a would have to be equal to 0, or x minus 8 would have to be equal to 0. So that leaves me with two solutions, x equals 2 or x equals 8. If I plug either of those values in, it'll return a 0 for the y. So that's why those things are my x-intercepts. So when I'm sketching my graph, I've got an x-intercept here at 2, and here at 8. So now, what's great about this is you have these 2 points, and you know that if they were to reflect about some axis of symmetry, they'll land on each other. Well, in order for that to happen, I need to find what that axis of symmetry is. That means I need to know what is the exact middle of 2 and 8. So I'm going to find the average of 2 and 8 to find the axis of symmetry. I'm going to take 2 plus 8 and divide that by 2 to find the exact middle. That gives me 10 over 2, which is 5. So my axis of symmetry is at x equals 5. This one you probably could have seen and just counted your way in to find the exact middle here at 5. But sometimes it's not always that easy, especially if you're dealing with fractions. So now I got to find the vertex. I do know that this is going to open up, so my vertex should be 5, comma, probably a negative number, so that this thing's going to open up. But let's go ahead and plug in 5 to see what that vertex is going to be. So I have y equals 3 times 5 minus 2 times 5 minus 8. So I end up with 3. All right, 3 again, and then a negative 3. When I multiply those out, I get a negative 27. And what I'm going to do, because that's a pretty large number, I'm just going to go down here and label this as negative 27. And now I have enough to sketch the graph of this parabola. Now the next piece is asking me for the y-intercept, which again you find by just plugging in 0. I didn't have to find it to graph the parabola, but it shouldn't be too hard to find. So if I plug in 0, I get 3 times 0 minus 2 times 0 minus 8. So I have 3 times negative 2 times negative 8. So I end up with a negative 6 times a negative 8, which is 48. And think about it, if you were to extend this all the way up, it'd be hitting here at 48. Next, we're going to look at when the parabola is increasing, decreasing, and its domain and range. So my domain, still all real numbers. My range, my lowest value is -27. Oh my goodness. Don't need that extra comma there. There we go. (27) to infinity. Let's see, increasing and decreasing. Again, this one starts out decreasing, so it's decreasing from -infinity until 5, and increasing from 5 to infinity. And that's it for a quadratic that's given in this intercept form. Now this last one, vertex form, which is also called standard form, sometimes it just depends on the textbook you're looking at, is the one that we're going to use most often when we're modeling. So in this vertex form, we have y equals a times x minus h quantity squared plus k. So here my a is still going to tell me if the parabola is opening up or down. And a is going to lie in the set of real numbers. Now what this h and k does is very special. It tells me what the vertex is. If you remember transformations from Algebra 2, this h tells you the horizontal shift and this k is going to tell you the vertical shift. So my vertex is hk. And notice this negative that's built in here. So in this example, I want to sketch the graph of the function y equals -2 times x minus 1 squared plus an 8. So right off the bat, I notice my h is equal to a +1 and my k is equal to a +8. So my vertex is 1, 8. So 1, 3, 4, 5, 6, 7, 8. So there's my vertex. I also notice that my a value is negative, so I do know this parabola is going to open down. It's the first one that we've had so far. Now if my vertex is at 1, 8, I also know that my axis of symmetry has to be at x equals 1 because this is my turning point. So my axis of symmetry is at x equals 1 because I know my vertex or my turning point has to lie right in the middle. And now I really just need one other point that's on the parabola, and then I can flip it over the axis of symmetry. So again, I suggest using the y-intercept because plugging in 0 is always going to be really easy. So if I plug in 0 to find the y-intercept, I have y equals -2 times 0 minus 1 squared plus an 8. So if I do my 0 minus 1, I get -1. Then I need to square it, giving me a +1. -2 times 1 is -2. Then I add that 8, and I get a 6. So 0, 6 will be my y-intercept. And now I flip that over the axis of symmetry. It is 1 unit away, so I go one more out, and I have a point at 2, 6 that corresponds. And here is the sketch of my parabola. And now I have all of this information that I need to fill out. Since we've done a couple of these together, what I suggest you do is pause the video, look at your graph, and go ahead and fill in that information. And then when you come back, you should be able to check your answers. So go ahead and pause the video now and fill in all of this information. Okay, so hopefully you've had plenty of time and now you can check your answers. You should have an axis of symmetry of 1, a vertex of 1, 8, and a y-intercept of 0, 6. We found all of that whenever we were graphing the function. The domain is again all real numbers. The range this time goes from -infinity up to a +8. It is increasing from -infinity to 1, and then it is decreasing from 1 to infinity. All right, so what I want to do here is I'm given the graph of a function and I want to actually find the equation. So take a look. This is a pretty special point. It's giving me the vertex. And so if it's giving me the vertex, I think I'm going to decide to use that vertex form. Because remember, that was y equals a times x minus h squared plus a k. And here was the vertex. So if the x-coordinate of the vertex is a 2, then I know my h is going to be equal to 2. And if the y-coordinate of my vertex is a -5, I know the k is equal to a -5. So when I plug this in, I get y equals a times x minus 2 squared minus a 5. Now the question is, what is the a value? Well, I do know that the a value has to be positive, it's greater than 0, because the parabola opens up, but I need to know specifically what it is. Well, in the graph, I've got this point that's explicitly given to me. I can also see the corresponding point here at 1, -2. So I could really choose to plug in either of those points, and I should be able to solve the a value. Since they gave me the 3, -2, I'm going to go ahead and plug that one in. So my y value is -2 equals some a value times 3 minus 2 squared minus a 5. Notice now a is my only unknown, and I need to solve and see what a value makes this equation true. So I have a times, well, 3 minus 2 is a 1, so in here this is a 1, and 1 squared is just a 1, minus 5. So I've got -2 equals a times 1, which is just an a, minus 5. And now to get a by itself, I just add 5 to both sides, giving me 3 for my a value. So my final answer, the equation in vertex form for this parabola is y equals 3 times x minus a 2 squared minus a 5. All right, so now this next question. How would I find the x-intercepts of this function? If I look at them, here's one slightly larger than 2, and here's one slightly lower than 1. What on earth are those? It doesn't look like they're clearly not going to be integers. So how would I find the x-intercepts of the function? Well, how do you find the x-intercepts of any function? You would plug in 0 for y and solve for x. So I've got 0 equals 3 times x minus 2 quantity squared minus a 5. We're going to review how to solve these types of equations here in 2 slides. But let's go ahead and solve here. Remember, if you have anything squared, first we're going to isolate that. So I'm going to add the 5 to both sides. And then divide by the 3. So I've got 5/3 equals x minus 2 squared. Now, I got to get rid of that square, so I'm going to take a square root of both sides. Remember, when you take a square root, you've got to add in that plus or that minus. So I've got plus or minus the square root of 5/3 is equal to x minus 2. And then I'm going to add 2 to both sides, giving me these two x-intercepts. So I'll have a positive 2 plus or minus the square root of 5/3. And I would need to simplify this if I'm keeping it in radical form, but most likely I'm going to put this in my calculator and find what the decimal approximations are. You can see when I do the 2 plus the square root of 5/3, I'll get that x-intercept that is greater than 3. And if I do the 2 minus, then I'm going to get the one that's slightly smaller than 1. Let's look at one more. I want to give the equation of this function that's graphed, and I notice what they're highlighting here is they've given me two x-intercepts, -1 and 3, and it looks like they've given me this vertex right here. So I could use vertex or I could use that intercept. I think I'm going to use the intercept just to mix it up. So if I'm using the intercept form, that p and that q are going to be those x-intercepts. So the p would be -1 and the q would be 3, and the order wouldn't matter. I could make the p 3 and the q -1. So I've got y equals a times x minus a -1, which makes that a +1, times x minus a 3. And now to find the a value, which again, I know the a is positive because this parabola is opening up, I'm just going to plug in this vertex. I just need one other point. So if I plug this point in, I get -16 equals a times 1 plus 1 times 1 minus 3. So order of operations, I'll have a times 2 times a -2. So when I clean this all up, I get -16 equals a -4 times a. And to get a by itself, I'm going to divide by the -4. So a is a +4. My final answer, y equals 4 times x plus 1 times x minus 3. So that's the equation of the parabola that's graphed. Now the next part said, now write this equation in standard form. That would be the y equals ax squared plus bx plus c. So if I'm going to rewrite this in standard form, first I'm going to have to multiply these two binomials here using a distribution property. So I'll have x times x is x squared, x times -3 is -3x, 1 times x is x, and 1 times -3 is -3. Now I'm going to clean up what's in these parentheses, giving me x squared. I can clean this up here, my like terms, minus 2x minus 3. And last, I'm going to distribute that 4. So I have 4x squared minus an 8x minus a 12. So if you were to graph this parabola here, you would end up with this exact same parabola. Y equals 4 times x plus 1 times x minus 3 is the same thing as y equals 4 times x squared minus 8x minus 12. And I could also rewrite this in the vertex form if I wanted as well. Okay, so the last thing I want to review with everyone is just solving quadratics and the different methods that we use to solve quadratics. The first one is just taking a square root, and that's actually what we used in the last slide on that first example where we had the graph and we were finding the equation that matched the graph. So if you have a quantity that's squared, your first step is just to isolate that quantity. So here, my m is being squared. So I'm going to isolate what's being squared. And to undo that, this 8, I'm going to subtract it from both sides. So I have m squared is equal to an 8, because 16 minus 8 is 8. And then once you have whatever is being squared by itself, you're going to take a square root. So now the square root of m squared is m. Don't forget your plus and minus. And then the square root of 8 can simplify. So the perfect square that is in the square root of 8 is 4. You can break this into the square root of 4 times the square root of 2. And the square root of 4 is 2. So I have m is equal to the 2 times the square root of 2, plus or minus. The next method I want to review with you all is factoring. So I gave you an example here where we actually don't have one side set equal to 0 because that really is your first step. So if I'm going to set one side equal to 0, I think I'm going to move everything to the left-hand side here since my x squared is already on the left-hand side. So I'm going to add 4x and make sure I line it up with its like term. I'm going to add 2, make sure it's added with this 10. So I get x squared equals an 8x plus a 12 equals 0. And I don't know why I put an equal sign there. I need that to be a plus. There we go. So x squared plus an 8x plus a 12 is equal to 0. And now I'm hoping, usually once I get it in this form, that it will factor. And this one does. If I factor this to be x plus 6 times x plus 2. Notice the 6 and the 2 will multiply to be the 12. And when I have the 6x plus the 2x, that'll give me the 8x. And now I'm using the zero product property to set x plus 6 equal to 0, giving me a solution of x equals negative 6. And I'm going to set x plus 2 equal to 0, giving me x equals negative 2. So my two solutions are negative 6 and negative 2. And notice your solution set is just two answers, so you have to use those curly cued brackets, just showing that your solution set is just the two values, not an interval of numbers. Now the next method I want to review with you all is completing the square. So here you've got x squared plus 6x minus a 1 equals 0. So if you're going to go through your options, you'd say, can I just take the square root? The answer is no, because of that 6x. I've got a quadratic and a linear term. Next stop is factoring. The only factors of 1 is 1, and so nothing's going to multiply to be 1 and add to be 6. So that's not an option. And so I'm going to go ahead and complete the square. So when I do that, I'm going to take the x squared plus the 6x, and I'm going to keep it on this side. But I want to move that negative 1 to the other side. So I'm going to do that by adding 1 to both sides. I'll show that here. If I add 1 to both sides, it cancels here, leaving me with nothing. And then 0 plus 1 is 1. I'm leaving a little bit of space on purpose. And what I want to do is I want to add the right number on both sides. I want to add in the term that will complete this square, making it a perfect square trinomial. So if I take the b value, this is only going to work if the a value is 1, which it is. So I'm going to take the b value, which is 6. I'm going to divide that by 2 and square it. So 6 divided by 2 is 3, and 3 squared is 9. So that's going to be my magic number that I'm going to add to both sides. And now notice, if I have x squared plus 6x plus 9, I've completed the square. It is a perfect square trinomial. It is x plus 3 quantity squared. And I have that as equal to 1 plus 9, which is 10. Now I have a quantity being squared, and I'm jumping to this taking the square root method. So I will take the square root of both sides. I'm left with x plus 3 equals plus or minus 10. And now subtract the 3. So I have two solutions. X equals negative 3 plus or minus the square root of 10. And the square root of 10 does not have any perfect squares in it. If you have a calculator, you can definitely get the decimal approximation of this. Now last, quadratic formula. And this is probably the one that I'm going to use as my last option. I should note too that this completing the square option, I really only use it if the a value is 1 and the b value is even. You can use it anytime, but that's when I usually think it's the easiest to use. Now completing the square, again, I didn't mean to say completing the square. The quadratic formula, it's the one that works every single time, but it takes the most amount of time. And so I would definitely go through these options and just make sure you're being most efficient when you're trying to solve a quadratic equation. So the quadratic formula, if you guys remember, you set your a, your b, and your c. You identify what those are. Then you have your formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. A lot of teachers will have a song for you to sing for this in Algebra I and in Algebra II. Hopefully by now you guys have that memorized and can pull it right out from your memory. So here, I've got x equals negative b. Well, my b is already negative, so when I do a negative 9, I get a positive 9. Plus or minus the square root. I like to do all of this in one step. So the b squared is 81. Minus, and now I'm going to do 4 times a times c. 4 times my a is 3, that's 12. 12 times 2 is 24. So there's my b squared minus my 4 times a times c. All over 2 times a, which is 3, which is a 6. 2 times 3 is 6. Now it's time to clean this up even further. I have my 9 plus or minus Now inside my square root, I've got 81 minus a 24. So that should be what, 57 all over a 6. So now for my last step, I need to make sure and see the square root of 57 doesn't simplify. And I do not believe it does. So I could plug each in my calculator and I could get the decimal approximations, or I can just leave it like this. If you do split it up, make sure both get divided by the 6. And then I could clean up that 9/6. So I could say 3 divided by 3 is 3/2, plus or minus the square root of 57 over a 6. And so that's just a review of solving quadratics and the different ways you can do that. You've got lots of options. So now you can go and you can do problem set 2.1. All of the problems that were not linear, you can finish that problem set, and it should give you a good amount of practice with all that we reviewed on linears and quadratics.